2012, when 15-year-old Jack Andraka's uncle died of pancreatic cancer, he decided to look into it. He found that the test doctors were using for pancreatic cancer was over 60 years old. It cost $800 and it wasn't very reliable. For this reason, over 85% of pancreatic cancer cases were detected too late, and the chances of survival were only 2%. As a bright and inspired young mind, Jack was able to devise a far better test procedure, which he took to the researchers at Johns Hopkin University. The result is a new dipstick-type diagnostic test that uses a paper sensor similar to that of a diabetic test strip. This strip that tests for cancer biomarkers in blood or urine is over 90% accurate and only costs 3 cents per test. Jack's ingenious test strip is now being used for early testing in other diseases as well. But this line of thinking doesn't just apply to the medical arena. We all know that we can't stop a hurricane after it's reached full intensity. We can't stop an avalanche after it's halfway down the mountain. We can't stop a tidal wave after it's already in motion. We can't stop a war after the bombs start dropping. We can't stop a plague once it's reached several continents. Naturally, this raises the question, can we learn to spot problems far earlier than we have in the past? As tiny humans battling the giant forces of nature, we need to do battle when the problems are still small. Jack was able to push the discovery of pancreatic cancer far closer to what I call Anomaly 0. Anomaly 0 is the first detectable sign that something is wrong. Every major disaster in the world begins with the shifting of a single molecule, the spark of electric energy, or some synapse firing in a different way. We may not be able to spot that first sign of change, but can get far closer than what we have detected in the past. So what exactly is Anomaly 0, and how close can we actually get to it and intervene before major damage begins? In 1969, chaos theorist Edward Lorenz used the theoretical example of a butterfly's wings flapping, where that simple movement became the root cause of a hurricane forming several weeks later on the other side of the planet. This has become known as the butterfly effect. This type of cause and effect relationship in chaos theory is used to describe a nonlinear system where the true sequence of events is so complex that it can only be sorted out after the fact. Anomaly 0 is different than that. Using an interventionist mindset, Anomaly 0 is the theoretical earliest possible point where danger can be confirmed, and it's viewed as a real threat. In virtually all cases, it remains theoretical because we are a long ways from both understanding each of the formative danger patterns and figuring out a way to intervene. The primary point of this discussion is to simply move the earliest red flags of detection far closer to the point of origin, so most disasters can be averted or at least detected early enough to mitigate a major portion of the damage. When a forest fire starts, it's relatively easy to put out the flames when it only covers a small space. Once it grows to a kilometer-sized patch, it becomes far more difficult to contain. At the same time, not all fires build momentum and turn into disasters. Fires in campgrounds, being carefully monitored by campers, rarely get out of control, so just scouting for fires in a forest will produce lots of meaningless data points, otherwise known as statistical noise. With enough data points, irregular situations will be flagged, monitored, and categorized on a danger level to determine when intervening actions will be required. If we think about change as measured along a 1,000-kilometer-long yardstick, Anomaly 0 is at the very beginning, and today's early warning systems are close to the end. Our goal should be to determine the earliest point that we can detect a problem. How can we detect dangers earlier, much earlier, when the situation is still controllable? Everything I've discussed so far is about building awareness and using this added awareness to halt something negative from happening. In this context, it becomes easier to visualize a far better earlier warning system for detecting things like natural disasters, corruption, health issues, disease outbreaks, infrastructure failures, environmental dangers, deviant behavior, and much more. Like a single pixel on a trillion pixel image, we quickly lose our ability to find significance in a single point. But it's exactly that, a tiny little signal on the masterpiece of life that determines what happens next. Every disaster has a life cycle with a definable beginning, middle, and end. As with every statistical bell curve, the size and shape of the curve represents the overall impact on society. But disasters are not inevitable. Human intervention can make a huge difference, and the sooner the better. We are currently building a massive digital infrastructure with the ability to monitor and assess changes happening anywhere in the world in real time. As we move into the big data era, our awareness of pre-disaster conditions will grow exponentially. Once we can sense an impending disaster, we will need to create response mechanisms capable of mitigating whatever forces are in play. I'm certainly not deluded into thinking we can eliminate all or even most of the catastrophes we'll be facing over the coming years. But we have an obligation to deal with these problems in a far more effective way than we have in the past. And all of this can happen if we focus our attention on the nano-size events happening at Anomaly 0.